So I want to end off here on something that, you know what, frankly, I've been worried about, and I try not to be worried about because there's plenty of other things to be worried about, and that is quantum computing. Google had an event a couple of days ago where they released Willow, their new quantum computer chip, which is, I mean, I don't know if I'm as deep inside of it as you are, but wow,
I wouldn't even consider myself an expert, but my understanding of the problem that they had it solve is a benchmark test that is incredibly difficult for even the most advanced classical supercomputers to solve. And I think the analogy they gave was the quantum computer Willow was capable of solving this benchmark test in 5 minutes when it takes our fastest computers about 10 septillion years to solve. And I was trying to think of different analogies to compare the differences between those two because our minds simply can't grasp how big that number really is. I mean, this is logarithmic math here, right? And the best analogy I could come up with is, Tom, you sitting there right now, your heart beats once, just one time. It would be like the difference of one of your heartbeats versus every heartbeat of every lifetime of every human that has ever existed through all time and every human that will ever exist in the future. That's the difference. One heartbeat versus 10 septillion heartbeats.
oh my god.
And it is incredibly faster. So obviously the exciting thing about this is that these quantum processors are basically able to do a lot more in parallel. Things can be processed a lot faster than the way CPUs or even GPUs process information. And as we know, AI is one of those industries that's dramatically impacted by compute time and compute speed. So I'm very, very interested in the commercialization of something like this for the AI space. I think obviously Google ends up being a clear winner in all of this. I would also be interested in knowing how they're going to use this technology to boost the performance of Gemini in the long run. What I can say, though, is that I don't think we're anywhere near to this being a commercial application. Like, it's fair to point out that Google's done this before, where they've made these huge accomplishments in technology. And the perfect example is Waymo. When they started this project for DARPA back in 2009, it took them, the next 15 years to get a commercial application in place where this would show up on the streets. And now we have, more rides being conducted in San Francisco by Waymo than ever before. I think it's going to be years before we see a potential application because there's just so much to iron out to get it to improve stability. But this is a very interesting turning point, and it's definitely one to pay attention to. So I'm going to be keeping a close eye on Google and their roadmap for this technology.
So I just want to play a quick 2-minute clip from Hartmut Neven, the Google VP of Engineering, who's talking about this to a newscaster. And the reason I want to play this is that I tried to find clip after clip after clip of Google actually talking about this, and it might as well be Mandarin as far as I'm concerned. Like, they're just like, even as a coder, I'm like, okay, but what does this actually mean? So let me just hear what he has to say here, and then we'll come back on the other side.
Yeah, the biggest news for today is that we developed a new, very high quality quantum chip. And this enabled two breakthrough computations. And one is an error correction, where we showed for the first time that as we use more qubits, the error rate comes down, and it comes down exponentially. The second important achievement, breakthrough achievement, is that we did a benchmark computation, took just 5 minutes on our new chip, that would take the top supercomputer 10 septillion years to perform. So 10 septillion, audience may not know, that's a 1 with 25 zeros. So it's a mind-bogglingly long time.
And it took 5 minutes. What I want to understand is what this benchmark test is, benchmark random circuit sampling. What does this prove?
Yeah, so this benchmark problem, we often say, is not a problem that people on Main Street have yet. but it's a suitable benchmark to compare different quantum processors to each other, or to compare quantum processors, quantum chips, against classical computers.
What's so mind-boggling about quantum more generally is that we have been talking about it for decades, but it always feels another 5, another 10 years off. Is it different this time, Hartmut?
Yeah, quantum computing is definitely not that field. There is steady progress, and our new chip that we just released, Willow, will form the basis to start doing useful computations that will enable or solve problems that humankind has.
Let's talk about those problems then. Everyone immediately goes to healthcare, drug discovery. Is that the most obvious place with which this sort of computing is going to be helpful?
Yeah, so the well understood killer application of quantum computers is to model systems where quantum effects are important. And that is more often the case than you may think. For example, if you want to understand how drugs, pharmaceuticals, bind to cells, or if you want to design a nuclear fusion reactor, or something as mundane as improving the batteries for an electric car, all these engineering challenges involve quantum problems. And their quantum processors are just the tool of choice to solve those problems.
All right. So two things I love.
Can I just say, I'm sure you're going to speak to his fashion choices here. And if not, then that should be your first call out, because I want to know who his designer is. I want the sunglasses and I want the NASA blanket shirt. That is awesome.
Well, what I loved about this was that first on the newscaster side, she's again and again in different ways. She's like, okay, so how does this matter? How does this affect our lives? And she kept trying to find ways of saying it, and he kept trying to say, and to him the simplest way of saying it was that anywhere where superposition helps with computation will be benefited by this. And he's trying to say to him that's the simplest I could possibly say. Like major engineering or brain chemistry, he's like, things like this that require like
stuff that's important to our daily lives here.
Exactly.
So I think that only proves my point that they're going to continue to use this in research realms. I'm not sure this goes to a commercial application very quickly.
Well, what matters the most to me, it was two things. One, I very much suspect, and I started reading on it today, but I'm going to read more about it, that the large language models have helped for these chips to be developed. And because Stephen Wolfram from Wolfram Alpha, he talks about the idea that he's been working on basically a computational language learning model, and he didn't realize that language models can actually help. That if you pair computation with natural language processing, then you get a type of computation that's way stronger than either, right? So LLMs have difficulty, and we all know this using ChatGPT and Claude or what have you. They used to have like great difficulty just doing 2 plus 2. But computational models can, but then computational models have very difficulty understanding what you're saying in natural language in order to output it. Well, there's whole industry now, this backend industry, where they're merging those two things. And so you do that with the type of research they need in order to develop these chips. Well, you have way more iterations that are happening way faster, and I would not be surprised if it's not that just this chip is going to help Google Gemini, but that Gemini helped make this chip. And so I think we're going to see this quadrillion dollar industry happening in the back end. Now, the other thing I thought was interesting, it's sort of tangential, but the thing that's also on my mind with quantum computing was that I also thought that quantum computing will break crypto, because crypto is based on cryptography. And I was like, okay, well, if you have this thing that could crack anything, then it should crack it, and it'll make Bitcoin and everything useless. But
yeah, that assumes. I think maybe. Sorry for interrupting, but I assume that you're seeing this as an opportunity to improve cryptography, right?
So there's been that discussion, but like you just said, these things are not commercially available. So it's like, can you imagine if it's in the hands of a few and they're able to crack it, but we don't get to see it on our end?
Yeah.
But Google specifically came out to put out articles that are saying, hey, this type of thing, even though it can do 10 septillion, uh, you know, better than classical chips, it can't crack cryptography. They said this. They said this is not one of those things, because I think there are even regulations in the United States that specifically say that if a technology can crack cryptography, then it falls under, like, I think, national security type things, which makes sense. And so they come out specifically to say that. So then I'm just like, okay, like, so what is this? It could do brain surgery, but then it can crack crypto. Like, what is going on here? What is actually true? And so to me, what I want to be looking for, and this is another reason I like markets, is that I like seeing moves in markets that are not explained by obvious macro or micro events. And if I see something like that happen, where Google, let's say the Google stock goes up, Microsoft stock goes up drastically, while some cryptocurrency coins drop, that might be a signal to me that, oh, there's some sort of crack within the crypto space, and maybe I should leave. So it's like a small thing. It's sort of like when I see bonds yields go up and the dollar go up, I go, okay, trouble coming. So if I see AI assets go up and crypto go down, okay, quantum computer problems. And it could also make it that invested in Google, in a sense, maybe could be a hedge against crypto falling. If you needed something to be like, well, how do I benefit if crypto falls because of this
Yeah.
quantum thing? Well, invest in the quantum computer company.
I think it's a bit of a leap. Like, the way to think about the Willow chip is more like ASICs, right? They're application specific integrated circuits. They are more capable of solving specific problems, not general purpose distributed workloads like hashing involved in brute force password cracking. So the start of this will be to solve these types of research problems that I think is it Hartmut? Is that his name? That's what I thought I saw
Hartmut,
earlier.
yeah,
Hartmut.
Neven.
Those are the types of applications he's referring to, and that's mainly because this isn't really a general purpose card. It can't solve all kinds of different problems the way a CPU or a GPU can. But obviously, they can build it to head in that direction. It's just going to take time. I think that the question around whether it gets into the wrong hands, probably not. It's not really the same thing as like our current LLMs, right? Where this is really software based that requires hardware in order to function. There was an explosion of competition in the LLM space, where people were providing new models that were almost on par with what OpenAI had developed. Obviously, Facebook's Llama was an example of that. I don't see anybody building any quantum computers in their basements, though, to compete head on with what Google has, and potentially having the ability to crack passwords or crack cryptocurrency cryptography well in advance of something like this being commercialized.
Fair enough. Yeah. So my worries of like there are teenagers with genome resequencing machines that used to cost $100 million that only cost $10,000 inside the garage. They're saying I don't have to worry about that for the quantum computers for a while.
I don't think so. I don't think so.
Excellent.